Automakers have tried just about everything to solve one of the biggest concerns people have about electric vehicles. They have built larger and larger battery packs, shortened charging times, and installed more charging stations along highways and across cities. And yet, that concern still is not completely gone away. Whether we are talking about Tesla or BYD, every company has developed its own way of reducing range anxiety. But so far, there still is not one single solution that works for everyone, everywhere, and in every situation. And that is exactly where Mazda has taken a step that caught the attention of the entire auto industry. The surprising part is that Mazda did not introduce some revolutionary new battery, and it did not unveil some breakthrough charging technology either. Instead, the company decided to bring back an engine that many people believed had already become part of automotive history. That engine is the rotary, a technology that was once deeply connected to Mazda's identity before gradually disappearing from the market. The rotary engine is so different and so unique that Mazda placed itself in the world map, and really, the rotary engine is what started this iconic love for driving. And that immediately raises a question. What is a technology that is more than half a century old doing in the middle of today's modern EV era? Has Mazda actually found value in an idea that most other automakers chose to leave behind? In this video, we're going to look at why Mazda made this decision, how the system actually works, and whether it could create a completely different path alongside major companies like Tesla and BYD. But before we get into all of that, if you have not subscribed to the channel yet, take a few seconds to hit that subscribe button so you do not miss what is coming next. To understand why Mazda would choose such an unusual path, we first have to understand the company itself. Whenever people talk about electric vehicles or new automotive technology, the first names that usually come up are Tesla, BYD, or Toyota. Mazda does not get mentioned nearly as often, but that does not mean Mazda is a small company, or that it lacks technical capability. In fact, Mazda has built a reputation over the years for choosing a different direction from much of the industry. Instead of immediately chasing every new trend that appears in the market, the company usually takes time to study it, understand what problem the technology is actually supposed to solve, and then develop its own approach. Mazda's story began in 1920 in Hiroshima, Japan. Back then, the company had almost nothing to do with automobiles. Its early business focused on cork products and industrial machinery. In other words, the automaker we know today actually started in an industry that had almost nothing to do with the cars we see on the road. But, over time, Mazda gradually moved into transportation. Then, in 1931, the company introduced its first vehicle, the Mazda Go, a small three-wheeled truck. By today's standards, the Mazda Go looks extremely simple, but at the time, it represented a major step forward for the company. It helped Mazda establish its first real position in the automotive industry. From there, the company expanded into passenger vehicles and slowly began developing its own engineering identity. One of Mazda's most distinctive characteristics has always been its engineering philosophy. The company is not only interested in creating something newer than what its competitors have, Mazda also wants that technology to remain useful over the long term. That way of thinking is one reason the company sometimes makes decisions that initially seem unusual or even a little risky. But Mazda's position has generally been pretty straightforward. If a technology still has potential, then maybe the problem is not the basic idea itself. Maybe it simply has not been developed far enough yet. Mazda also tends to avoid making the kind of massive claims we sometimes hear from other automakers. The company does not constantly hold giant stage events and declare that every new technology is about to transform the entire automotive world. Instead, it puts much more emphasis on engineering and product development. As a result, some Mazda technologies only began getting widespread attention after they have already reached production vehicles and customers are actually driving them on public roads. That does not mean Mazda ignores marketing, of course, because every company has to tell customers about its products. But Mazda's reputation has historically been tied more closely to its engineering choices and driving experience. That is also one reason many Mazda owners choose another Mazda when it is time to buy their next vehicle. Mazda does not design its cars around a simple checklist of features. The company pays close attention to how the vehicle responds to the driver, including steering feel, chassis balance, comfort, and dependable long-term performance. Today, Mazda vehicles are sold in more than 120 countries around the world, which shows that the brand is far from being limited to Japan and has built a meaningful global presence. Mazda sells around 1.2 million vehicles per year. That is obviously lower than giants such as Toyota or Volkswagen, but it is still enough to put Mazda among the world's major automobile manufacturers. Looking at the company's current lineup, sport utility vehicles such as the CX-5, CX-60, and CX-90 are among its most popular products. These vehicles have seen strong demand across different markets because Mazda focuses heavily on comfort, safety, solid build quality, and balanced driving dynamics. That makes them appealing not only for everyday commuting, but also for longer road trips. Mazda also tries to deliver something close to a premium experience without pushing prices into extremely expensive territory. Interior materials, fit and finish, seat comfort, and cabin design can sometimes remind buyers of vehicles that cost considerably more. Because of that, many customers feel like they're getting more quality for the money they're spending. And that overall way of thinking helps explain why Mazda often stands apart. The company is not trying to sell the most vehicles in the world or dominate the headlines every week. Instead, it focuses on practical solutions that can last, work well, and provide real value to customers. And there may be no better example of that philosophy than the story of the rotary engine. The complete story of the rotary engine. The rotary engine is making headlines again, but its story did not begin in the electric vehicle era. To understand why Mazda never completely gave up on it, we have to go back to the years following World War II. Hiroshima was one of the cities devastated by the war. Many industries there were nearly wiped out, and rebuilding took years. Mazda was based in that same city. Under circumstances like those, most companies probably would have chosen the safest path possible. Mazda thought differently. The company did not want to survive simply by producing the same kinds of vehicles as everyone else. It wanted a technology that could give the brand its own identity in an increasingly competitive automotive industry. With that goal in mind, Mazda acquired the rights to rotary engine technology during the 1960s. What makes that decision interesting is that many major automakers had also studied rotary technology at the time. But most eventually decided not to pursue it, and the reason was easy to understand. On paper, the rotary engine looked incredibly interesting. In real-world operation, however, it came with several major problems that gave manufacturers plenty of reasons to hesitate. The first major weakness was fuel consumption. A rotary engine is built very differently from a traditional piston engine, and because of that design, the air-fuel mixture does not always burn as completely or as efficiently as it can in a conventional engine. That has a direct effect on fuel economy. Put simply, if two vehicles are producing similar power, the one using a rotary engine may consume more fuel in many situations. As the global market gradually moved toward more fuel-efficient vehicles, that became a serious disadvantage. The second major issue was heat. Rotary engines can generate significant heat during operation, and those high temperatures put additional stress on several internal components. One of the most important is the apex seal. In simple terms, the apex seal is a small but critical component that helps maintain proper sealing inside the engine. If those seals wear too quickly, engine performance begins to suffer, and maintenance costs can increase as well. That is why the long-term durability of rotary engines remained a controversial subject for many years. But Mazda did not walk away when it ran into those problems. The company kept researching and improving the design for years before introducing the Cosmo Sport in 1967. This was not simply another new sports car. For Mazda, the Cosmo Sport was proof that a rotary engine could actually work in a real production vehicle. The car quickly attracted global attention because Mazda had taken a technology that many other manufacturers had essentially given up on and turned it into something people could actually drive on public roads. Over the years that followed, the rotary engine became an increasingly important part of Mazda's identity. The company installed it in several different vehicles, and Mazda's name eventually became closely tied to rotary technology, especially among sports car enthusiasts. Drivers loved the distinctive engine sound, the smooth way it delivered power, and the unique driving character created by the design. So, how does a rotary engine actually work? In a conventional engine, pistons move up and down repeatedly to generate power. A rotary engine does not work that way. Instead, it uses a rotor shaped roughly like a triangle that spins continuously inside a specially shaped housing. As the rotor moves, different chambers inside the housing go through the intake, compression, combustion, and power phases. Because the engine does not rely on the same large number of components moving up and down like a traditional piston engine, its overall architecture is very different. One major advantage is compact size. Compared with a conventional engine that needs more room to perform the same basic job, a rotary engine can be made significantly smaller. It has even been described as compact enough to fit into a space roughly the size of a watermelon. That smaller size can help reduce weight while also giving engineers much more freedom when arranging other systems inside the vehicle. And that is one of the main reasons Mazda stayed committed to the technology longer than almost any other manufacturer. But those advantages could never completely erase the weaknesses. Over time, emission standards around the world became much stricter. Buyers also started demanding better fuel economy, higher durability, and lower maintenance costs. Meanwhile, the rotary engine continued struggling with fuel efficiency and long-term reliability. Mazda kept improving the technology, but the market was changing quickly. Eventually, production of the RX-8 ended in 2012. It was Mazda's last major production vehicle to use a rotary engine as its primary source of propulsion. Once the RX-8 disappeared, most people assumed the rotary story was finally over. It seemed like a technology that had earned a special place in automotive history, but could no longer meet the demands of a changing world. Mazda, however, never completely forgot about it. Engineers at the company continued studying the design and asking whether modern materials, better controls, and newer engineering techniques could solve some of the old problems. Many years later, that question finally received a new answer, but there was one major difference. This time, the rotary engine was no longer being asked to turn the wheels directly. Instead, Mazda gave it a completely new job inside an electric vehicle, and that is where the modern Mazda rotary story really begins. Why did Mazda bring the rotary engine back? When most of the auto industry is spending huge amounts of money on bigger batteries and faster charging systems, why would Mazda go back to a technology that has been around for decades? The answer comes down to a problem almost every potential EV buyer has thought about. Electric cars can be great to drive. They are quiet, they deliver power almost instantly when you press the accelerator, and they can feel smooth and comfortable in everyday traffic. But the moment someone starts thinking about a long road trip, the conversation can change. What happens if the battery gets low in the middle of the trip? How far away is the next charging station? Will there be a line when you get there? And even if a charger is available, how long will you have to wait before you can get back on the road? Those questions remain one of the biggest reasons some customers still hesitate to switch to a fully electric vehicle. The most obvious answer is simply to install a larger battery. But a larger battery does not only give you more driving range, it also makes the vehicle heavier, pushes the price higher, and requires more raw materials to manufacture. So, continuously adding more and more battery capacity cannot be the ideal answer for every vehicle. Mazda looked at the problem from another angle. What if the vehicle did not need to carry an enormous battery all the time? What if it could drive primarily on its electric motor, but whenever necessary, the system could generate additional electricity on its own and keep going? If that worked, the driver would not have to constantly worry about finding another charging station. That is the basic idea behind the range extender concept Mazda used in the MX-30 REV. At first glance, some people might assume this is just another hybrid with a different name. But there's one very important difference in the way the system operates. The rotary engine does not send power directly to the wheels. In a conventional gasoline vehicle, the internal combustion engine generates power and sends that power through the drivetrain to move the vehicle. Mazda's system works differently. The electric motor is responsible for actually driving the wheels. That means the vehicle can still feel like an EV when you are behind the wheel. The rotary engine has one primary job: When the battery charge falls below a certain level, the rotary engine starts operating as a generator and produces electricity. That electricity is then sent into the vehicle's electrical system, allowing the electric motor to continue receiving the energy it needs. That is why Mazda does not simply see this as the return of the old rotary engine. The company has completely changed what the engine is being used for. In the past, the rotary directly propelled the vehicle. Now, its main job is to generate electricity. That change in responsibility is especially important because the engine no longer has to constantly speed up and slow down based on how the driver is using the accelerator. Instead, the rotary can operate within a more stable and efficient range. For a technology that historically struggled when forced to operate across many different conditions, that can be a significant advantage. Mazda has essentially placed the rotary in an environment where some of its strengths can be used more effectively while reducing the impact of several old weaknesses. But changing the engine's role was not enough by itself. If Mazda had simply taken an old rotary engine from decades ago and dropped it into a modern EV, the same issues involving heat, fuel consumption, and durability could easily have returned. So, the company also had to redesign the engine itself. What has changed in the new rotary engine? One of the first major improvements is direct fuel injection. In older rotary engines, the fuel mixture did not always burn as completely or efficiently as engineers wanted, hurting fuel economy and allowing some fuel to pass through the combustion process without being used as effectively as possible. In the newer design, fuel can be delivered into the combustion chamber with much greater precision. That helps improve how efficiently the fuel is used. It does not mean every fundamental weakness of the rotary engine has suddenly disappeared, but the combustion process has been improved significantly compared with older generations. Mazda has also made several changes to the combustion system itself. When fuel burns more efficiently, more useful energy can be extracted from it, instead of being lost unnecessarily. The overall goal is to create a better balance between efficiency, compact size, and reliability. Temperature management is another area that has received major attention. Heat has always been one of the most common complaints associated with rotary engines. High temperatures can put extra stress on internal parts and speed up wear. So, Mazda redesigned the way heat moves through the engine and the way that heat is removed. Cooling passages were changed so coolant can reach critical areas more effectively. When engine temperatures remain under better control, internal components experience less thermal stress. Mazda also improved airflow around the engine, so excess heat can escape more quickly. On an engine design with such a long history, these are not necessarily flashy changes that a driver can immediately see, but they are exactly the type of improvements that could determine whether the technology is durable enough for long-term real-world use. Another upgrade is the use of diamond-like carbon coating, commonly known as DLC. This is a hard surface coating applied to components that experience regular friction. The idea is to slow down wear and help those parts maintain consistent performance for a longer period of time. This kind of coating is not limited to the automotive industry. It is also used in other high-performance applications where friction and durability matter. But, if there is one component most closely associated with the rotary engine's reliability problems, it is still the apex seal. These small parts are responsible for maintaining the necessary seal inside the engine. On older rotary engines, they could wear relatively quickly and create concerns about long-term maintenance costs. Mazda says it has now introduced new materials and a redesigned apex seal in an effort to improve durability. Whether those changes completely solve the long-standing concern will only become clear after years of real-world use. But, at the very least, it is obvious that Mazda has spent a great deal of effort addressing one of the exact areas that caused the most trouble in the past. All of these changes are aimed at one thing: making the rotary engine more dependable than it used to be. The technology has always been known for being compact and smooth. Mazda wants to preserve those advantages while reducing as many traditional weaknesses as possible. Even today, compact size remains one of the rotary engine's most important benefits. Compared with a conventional piston engine, a rotary requires less space, giving engineers more flexibility when arranging the battery, electric motor, and other components. A compact system can also help with vehicle weight distribution. When the engine takes up less room and can be positioned more effectively, the overall balance of the vehicle can improve, which can directly affect cornering and everyday handling. So, from Mazda's point of view, this is not about bringing back an old technology simply because of nostalgia. The company is trying to transform an older design into a component that actually makes sense within a modern electric vehicle architecture. How successful those changes really are will have to be judged through customer experience over the coming years. Its impact in Europe and other markets. Over the past several years, electric vehicle sales have grown rapidly across Europe. Many countries introduced new policies, tax incentives, and other programs designed to encourage people to switch to electric cars. But that growth has also exposed another problem. In many places, the number of EVs has increased faster than charging infrastructure has expanded. In large cities, finding a charger usually is not especially difficult. But once drivers leave major urban areas and head out on longer trips, charging stations can become much less common in certain regions. And even when you reach a charging station, you may still have to wait because other vehicles are already using the available chargers. That means the real-world charging experience is still not as simple for everyone as some buyers may have expected before purchasing an EV. Countries such as Germany, France, and the Netherlands have all seen steady growth in electric vehicle adoption. Their charging networks are generally considered relatively well developed, but the experience is not identical everywhere. Large cities and major highways tend to have better charging infrastructure, while smaller towns and less populated areas may offer fewer options. That difference creates a group of customers who want to drive on electricity most of the time, but still want extra peace of mind when they need to travel long distances. At the same time, another noticeable shift has been taking place in the market. A few years ago, many people believed the future would belong almost entirely to fully electric vehicles. More recently, however, hybrids and range extender systems have continued receiving attention as well. The reason is not simply the technology. It also comes down to how people use their cars. Not every household can install a charger at home. Not every driver covers the same distance every day. And charging networks are not equally developed in every country or region. That creates demand for a vehicle that can provide many of the main benefits of electric driving, while still offering another layer of security when longer trips are necessary. Mazda appears to have recognized that trend relatively early. Instead of assuming that every customer over the next few years would want an EV with an enormous battery, the company recognized that some buyers want an electric driving experience without becoming completely dependent on public charging infrastructure. Products like the MX-30 REV were designed around that kind of need. Mazda is not trying to use this system to replace every fully electric car. It is simply offering another option for customers whose driving conditions and lifestyles are different. Someone who spends most of the time driving around the city on electric power, but occasionally takes longer road trips, could see real practicality in this type of system. What makes Mazda's choice even more interesting is that the company moved in this direction while nearly the entire auto industry was putting enormous focus on battery electric vehicles. Choosing a different path does not mean Mazda is opposed to BEVs. The company simply believes that markets around the world do not all have exactly the same needs. Some regions already have extensive charging networks. Other areas may still need years of infrastructure development. In that kind of environment, there could still be room for several different technologies at the same time. And that is one reason Mazda's strategy is getting attention. This is not only a story about an old engine unexpectedly returning, it is also about the way an automaker observes changes in customer needs, and then develops a solution aimed at the people it wants to serve. In the end, customers will decide which technologies gain the most traction in the years ahead. But Mazda has at least demonstrated one thing. Rather than simply following whatever trend is currently dominating the industry, the company still wants to study the problem for itself and choose its own direction. What does this mean for Tesla and BYD? If Mazda's approach actually proves successful, could it have an impact on major companies such as Tesla and BYD? The answer is not simple, because all three companies operate with very different strategies and philosophies. Tesla has focused on fully electric from the very beginning. The company believes the future belongs to battery electric cars and has built its entire ecosystem around that idea. Large battery packs, the supercharger network, and a heavily software-driven experience are some of Tesla's biggest strengths. But that model also depends significantly on charging infrastructure. In areas where chargers are widespread and convenient, owning a Tesla or another fully electric vehicle becomes much easier. In places where charging stations are still limited, however, some customers may continue to hesitate. BYD follows a different strategy. The company is not only invested in electric vehicles, but has also spent years developing hybrid models. One of BYD's biggest advantages is manufacturing scale. The company produces its own batteries, controls many important components internally, and has the ability to build vehicles in extremely large numbers. That level of supply chain control helps BYD offer competitive pricing in many markets. Mazda does not fit perfectly into either the Tesla or BYD model. It is not trying to become the world's highest volume automaker, and it is not trying to win a race to build the largest battery pack. Mazda's identity has long been centered on engineering and the driving experience. So, a range extender system where the electric motor creates an EV-like driving experience, while a rotary engine works as a generator when necessary, fits naturally with the company's broader product philosophy. Another important factor is that Mazda often positions many of its vehicles closer to the premium end of the market. That means the company is not competing on price alone. Mazda tries to differentiate its products through build quality, balance, and the way the vehicle feels from behind the wheel. So, the company's goal does not necessarily have to be a direct confrontation with Tesla or BYD on every front. Instead, Mazda's trying to offer a different kind of choice to a different group of customers. The competition here is not only about production scale, it's also a competition between different ideas. Tesla's strength is its EV ecosystem. BYD has a major advantage in manufacturing capability and supply chain control. Mazda, meanwhile, is trying to carve out its own space through a different engineering approach. Which strategy eventually proves most effective will depend on market conditions and what customers actually want. But one thing is worth paying attention to. Mazda is showing that every EV problem does not necessarily have to be solved by increasing battery size or building more and more charging stations. Sometimes, looking at the same problem from a different angle can lead to a completely different answer. Future plans and the hydrogen version. Mazda is not only studying ways to address today's needs, the company also wants to prepare for possibilities that could emerge in the future. One part of that strategy involves a hydrogen-powered rotary engine. The technology is still at a relatively early stage, but Mazda has filed related patents, which suggests the company is actively exploring several different energy options. Mazda's idea is pretty interesting. If the rotary engine can currently operate as a generator to produce electricity, could that same basic system eventually run on hydrogen instead of conventional fuel? If so, Mazda might not need to create an entirely new vehicle platform for every different type of energy source. Instead, one core architecture could potentially be adapted to work with multiple fuels. For now, this is still a future-oriented concept, and Mazda continues researching it. But the company is certainly not alone in paying attention to hydrogen. Japan has invested in hydrogen technology for many years, with both the government and several automakers viewing hydrogen as one possible energy option for the future. Germany has also been developing a number of hydrogen projects, particularly in industrial applications and heavy transportation. South Korea has launched several initiatives designed to create a broader hydrogen ecosystem. At the same time, some countries in the Middle East are investing heavily in the production and export of green hydrogen. But there is one critical point that has to be understood. Building a hydrogen-powered vehicle is only half of the problem. For the technology to become widely usable, the market also needs hydrogen refueling stations, a dependable supply network, and safe storage systems. If those pieces of infrastructure do not exist at sufficient scale, bringing hydrogen vehicles to everyday customers will be extremely difficult. That is why hydrogen is still viewed more as a future possibility than a solution that is ready to replace everything today. What is interesting about Mazda's thinking is that if hydrogen infrastructure eventually becomes strong enough, the company hopes it will not have to start from scratch. Instead, Mazda wants a platform that can adapt to different energy sources. In other words, the current system that uses a fuel-powered rotary engine as a range extender might one day be modified to run on hydrogen. If that actually becomes possible, it could represent another step in the evolution of automotive energy systems. For most of automotive history, transportation depended primarily on traditional gasoline and diesel engines. Then hybrids arrived, followed by the major shift toward battery electric vehicles. Now, some experts believe hydrogen may also find a place in certain applications in the coming years. But nobody knows exactly how quickly that will happen or how large the market will ultimately become. And that uncertainty may explain why Mazda does not want to bet its entire future on a single technology. Instead of trying to predict exactly which energy source is guaranteed to win, the company continues exploring several possibilities and trying to keep practical options available so it can adapt as market needs change. How quickly hydrogen develops over the next several years will depend heavily on infrastructure, cost, and government policy. A hydrogen-powered rotary could become part of Mazda's future, or it may ultimately remain limited to certain specific applications. In the same way, today's rotary range extender still needs more time to prove whether the improvements in durability, thermal management, and efficiency are truly good enough for long-term, real-world use. But that is also what makes Mazda's strategy so interesting. While much of the industry is trying to solve the EV challenge with larger batteries, faster charging, and broader charging networks, Mazda is asking a different question. Can you preserve the electric driving experience while reducing total dependence on a large battery pack and public charging stations? And that is why the return of the rotary engine is so different this time. Mazda is not trying to put RX-8s back on the road exactly the way they were before, and the company is not claiming that the rotary engine will replace electric vehicles or become the one answer to the future of the auto industry. Instead, Mazda is taking a technology that always had real strengths as well as serious weaknesses, giving it a job that may fit those strengths much better, and using modern engineering to address some of the limitations that existed in the past. Whether this approach becomes successful enough to put real pressure on companies like Tesla or BYD is still far too early to say, but Mazda has at least demonstrated that a technology once considered outdated is not necessarily useless forever. Sometimes the most important question is not how old a technology is, but whether it has finally been given the right job. And if Mazda can make the rotary engine dependable in this new role, an engine that many people believed had disappeared from automotive history could end up becoming part of the electric vehicle future itself. If you found today's information useful and want to keep watching simple, easy to understand, and reliable videos about cars, electric vehicles, and new technology, make sure to subscribe to the channel so you do not miss what comes next.